Hello everybody! Welcome to Creating the Basic Adaptable Game Engine Library, Part 44, Action Class Code. In the previous video, we introduced actions. Actions are going to be objects which encapsulate a method which is automatically applied to a sprite over time. This will be very useful for continuous actions that happen over a finite amount of time. It'll be much easier than keeping track of the time required for each one of those individual actions ourselves. So, in this video, we're going to start creating the code base for it. And creating the action class will take a lot of time actually. We're going to return to this class time and time again in the videos that follow. In this particular video, we'll just worry about the basic framework and a few static methods to produce some commonly used actions, such as movement and rotation. All right, first, let's go ahead and open up our development environment. So here we are in IntelliJ with the latest version of our code base. Let's go ahead and create a new class. So I'll go ahead and make a new Java class. This will be called Action. Alright, so in the action class, the main part of this class is going to be a function which is applied to a sprite over time. So first we're actually going to create an interface, right? And that specifies what these functions will look like. So let's say, and this is going to be an inner interface too. I'm not creating kind of a separate class in this case, because, or a separate file, because this interface is only going to be used by the action class. So we'll say this is a public interface. I'll just call it function, because that's kind of what it is. And so every action function will contain a method which returns a Boolean. That's going to be the status of the function. And the function it stores, we'll say it has to contain a function called run, which requires a sprite that serves as the target for the action. We'll also take in delta time, how much time has elapsed, and a double for the total time which has elapsed. All right. Again, since this is an interface, I don't really need to specify this code. And this will be specified by classes which implement this for us. All right, what other information do we need in an action other than this function which is applied? Well, we'll actually have the action monitor the total time as well. And so total time can be used in two ways. And so let's create a public double total time. Right, this represents the total time that's elapsed since an action has started. And each action, well, obviously, I probably should have put this one first. It's going to store, an action is going to store a function, which we'll call function. I need a couple of constructors for the action class, and I'll do two. I'll do first and default constructor. So public action, right, for function we won't set that, but we'll say total time is equal to 0. And then maybe we'll do a parameterized constructor where you just supply the function. So public action that takes in a function called f, and we'll say that function equals f. Again, total time, the time when you start, that should be equal to 0. Now each action, we need to be able to apply an action to a sprite. And so, and how will an action be applied to a sprite? The action will run the method stored in the function. Right? It'll activate the run method stored in its function. And so we need to create something, we'll call it Boolean apply. And we apply this to a target. Also, we need to know how much time has elapsed since the last method. Oh, and this also has to return a Boolean. So what we're going to do here is the action can apply itself by running its function on this target. And delta time, we can use that to increment the total time which is stored within the action itself. So total time plus equals delta time. And then we're going to return the results of, within the function, there's a method named run, and that is going to be applied to the target. It's going to need delta time and also total time. Again, each action keeps track of its own total time and how long that action has been running. And again, total time might be useful in this function. Some functions might just be like a pause or a wait function for a few seconds, in which case it needs to be aware of this total time. And finally, one thing which could be helpful in the future, and we'll just lay this groundwork now, in case you want to reset an action. It's not clear why we want to do this yet, but this will come in handy. And right now is probably the best time to add this in. A reset just means setting the total time back to 0. And as a spoiler, this is going to be used if we want to repeat an action, which we'll discuss in a future video. All right, so this right here is the basic functionality of an action. However, we need a way to create actions, right? And we'll do that with some static functions. And so in this part, we'll set up static functions to create actions. More specifically, action objects. All right, so let's say public static. This returns an action. And for our first one, let's do maybe one of the easier ones, move by. Right, you want to move by some amount, which we'll call delta x, and double maybe delta y. Right, so we want to move by some amount in the x direction and some amount in the y direction. And also, let's see, can I fit this on one line? We also need to know how long it's going to take to move through these amounts in the x and y coordinates. So that'll be something called duration. Right, so this is going to be a static method we'll be able to call that'll set up an action for us. So we need it to return a new action. Now, the heart of this is going to be specifying a function which moves a sprite by these amounts over this amount of time. So as we're returning a new action, what we'd like to do is, well, we're actually going to create the function right in here. Right, so in this action, right, this new action needs to take in a function, and I'll write that using something called lambda notation. Right, it's a way of specifying an inner class. So sprite target, double delta time, and double total time. Right, in fact, let me make this a little bit shorter. I'll call this dt for delta time and tt for total time. All right, so in this lambda notation, I do a dash and then a greater than symbol. That's supposed to look like an arrow, saying these are your inputs, and then we're going to apply the code within these parentheses here. So what do? Well, the target, which is a sprite, see, do we have a, oh, we do, we have a move by function. Right? How much are we going to move this sprite by? Well, it depends on delta x and delta y. It depends on what the speed is going to be, which we can calculate from the duration. Right? So the speed in the x direction is pixels divided by time. Right? So we're going to move by delta x divided by duration. But then that just gives us the overall speed. We also have to take into account delta time, how much time has elapsed. Yes, that's times dt. That'll tell us how much to move by in the x direction. Similarly, we need to put in the same information for y, so delta y divided by duration times dt. Right? And that tells us what the action is going to be. Now, how do we know that we're done? Right? This is when total time comes into play. right? Once the amount of total time becomes greater than the duration, right? If the function or the action has been running for longer than the duration, we know that it's done. And so we need to return a Boolean, remember. In this case, when total time is greater than or equal to duration. Right, in that case, if this is true, the action is finished, and we can potentially remove it from that list. All right, so we're going to return this action. Let's see, oh, I need a semicolon here. And that's basically going to be the format for all of these static methods. Right? They create an action for us by returning an action, and that action defines the function which is going to be applied to our target sprite. All right, let's do a couple more just so we get familiar with this pattern, because we're going to see this pattern a couple of times. Let's say we want to do a rotate by action. Let's scroll up a little bit. Let's say public static action rotate by. In this case, we need a double for the angle, right? Maybe I'll call that delta A for angle. And again, double duration, right? We need to know how long we have to rotate through a given angle. Okay, so again, just like before, we want to return a new action, and a new action, right? Within this action, we need to define this function. And so let's say a function which takes in a sprite called target, double dt for the delta time, and double tt for total time. And then I'm making this arrow notation. And then what code do we want to run? Well, let's do target dot rotate by. And the calculation, again, is very similar to this calculation from up above. Right? To figure out how much we want to rotate by, first take the rotation speed, which is, again, this is the total amount, this is the total duration. We can divide those to get the rotation speed. So delta A divided by duration. But then that tells us the overall speed. To convert that into the number of degrees that we want to rotate by, we need to multiply that by delta time. Okay, so we're going to rotate by that amount. And again, at the end, we need to know if we're done or not. So we'll say return total time greater than or equal to duration. Right? And not all functions will return this value, but very many of them will. Finally, I'd really like to do a fade out action. Need a semicolon there. We need to do a fade out action. Again, that's a very common thing we see in video games. So let's create public static action fade out. In this case, we really only need to know how long the fade out process is going to take. And so we don't need any other values. We assume we're going from 1 to 0. So in this case, all we need is the duration. The format's going to be hopefully familiar. These static functions each return a new action. Within the constructor of that action, we're going to define our function, which always takes in a target, delta time, and total time. What are we going to do here? Well, let's say target.opacity. We're going to subtract. Well, let's see. We need to know, well, we're going from 1 to 0, right? So this duration kind of tells us how quickly we're fading out. And so we want to fade out by this amount, and we need to take delta time into account, as before. One thing which makes this function different from earlier functions is we don't really need to specify something like delta x or delta a. In this case, we know that we want to fade out from 1 to 0. Right? So the total amount of fade is always going to be 1. So what we want to write here, kind of the analogous expression to this in terms of reducing opacity, is going to be 1 divided by duration times delta time. And so we want to subtract that. Just in case of rounding errors, weird things can happen if this happens to get less than 0. So let's also say if somehow the target opacity ever becomes less than 0, let's make sure we set it back to a reasonable value. Target.opacity, we'll set that equal to 0. And finally, we can return when the total time is greater than or equal to the duration. And this is an action which we can use to fade out a sprite over time. All right, so that's plenty of material for this video. We've created an action class and some static methods which can do some commonly needed actions. So in the next video, we'll see how to integrate actions with the sprite class, and we'll even add a few actions to our starfish collector game just to test them out. And that's it for this video. Thanks for watching.